Okay, so this is the key, and this key will be for both versions 1 and 2. So on number 1, this was in the same version on both versions. Now this is a quadratic equation, and you want to solve by factoring. All right, so if I'm going to solve this by factoring, I've got to first of all write it in standard form. So I'm going to bring all terms to one side because I need 0 on the other side, so I can use the zero factor property. So remember, we have to use the zero factor property. All right, so if I do that, I'm going to get 2x squared minus x minus 10 equals 0. Okay, so the next step is to factor. All right, so the GCF of this quadratic expression is 1. So then I'm going to go and factor as two binomials. And when I do that, I'm going to get 2x minus 5 times x plus 2. And again, you have time to check these to make sure you get all these three terms. So the outer is 4x, the inner is a negative 5x, and I do get a negative x. And the negative 5 times 2 is a negative 10, and then 2x times x is 2x squared. All right, now that's where the zero factor property comes in. So if I have two or more factors whose product is 0, then one of these must be 0. So I get 2x minus 5 equals 0, x plus 2 equals 0, and then notice I went from a quadratic equation to two linear, and I just solved each of these linear equations. So I'm going to add 5 to both sides, so I get 2x equals 5, and then to get x by itself, I'm going to have to divide both sides by 2, and so one of your solutions is 5 halves. All right, the other solution is subtract 2 from both sides, and so I get x to be negative 2. All right, and if you had time, you could go back in your equation and verify that these are your solutions. Okay, number 2, you want to solve this quadratic equation by using a quadratic formula. All right, so the quadratic formula, remember, is this: the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so it does help. Okay, so it does help if you list A, B, and C. Now again, this must be in standard form, and it is. So A is coefficient of x squared, which is 2. B is the coefficient of x, which is negative 4. And then C is your constant, which is negative 1. And then we're just going to substitute into the quadratic formula. So I get x equal, so I'm trying to find the solutions. So this says I take the opposite of b. Well, b is negative 4. This becomes a positive 4. Plus or minus the square root of b, which is negative 4. I'm squaring it. Minus 4 times a. A is 2. Times c, which is negative 1. And all of that's being divided by 2 times a, and a is 2. And so I get 4 plus or minus the square root of negative 4 squared 16. 16. And then a negative 4 times 2 times a negative 1 is a positive 8, all divided by 4. So I get 4 plus or minus the square root of 24 divided by 4. All right, and remember, you need to simplify radicals if possible. And so the square root of 24, I can simplify because 4 is a perfect square, and 4 goes into 24. So I can write this as square root of 4 times square root of 6. And square root of 4 is 2, so you get 2 square root of 6. So that's what this becomes. So it becomes 4 plus or minus 2 square root of 6 divided by 4. All right, now notice that 4, 2, and 4, these right here, not this, but this, the coefficient in front of the square root of 6, the factor in front of the square root of 6, 4, 2, and 4, they're all divisible by 2. So I can write this as 4 divided by 2 is 2, 2 divided by 2 is 1, so that's 1 square root of 6. And then 4 divided by 2 is 2. All right, so there's your solutions. So you can write in the brace, or you can just say 2 plus or minus square root of 6 over 2. You could have written it as separate fractions. There are multiple ways you could have written this. 2 plus the square root of 6 over 2, comma, 2 minus square root of 6 over 2. Some of you went even further and you said, this right here, you even did this. You said 4 divided by 4. Now I got to write this out. 4 divided by 4 plus or minus 2 square root of 6 divided by 4. And then you would get 1 plus or minus, and then that becomes 1/2. So square root of 6 divided by 2. All right, so these are all ways of writing the solution. Okay, now let's look at the next one. So page 2. All right, let's see, page 2. Okay, now this is version 1. So this is going to be from version 1. So this right here is version 1. So notice I want to use a squared property. So we're going to use a squared property whenever we have an expression squared equal a number, then you're going to take the square root of both sides. All right, so, and that's what I have here. So I'm going to go ahead and rewrite this over. And so when I take the square root of both sides, don't forget the plus or minus, I get the square and the square root of each other, so I get 2x minus 3 equal plus or minus, and the square root of negative 16 is 4i. And then a couple more steps and you're done. Just add 3 to both sides. You've got to solve for x. So you get 2x equal 3 plus or minus 4i. And then we divide by 2. We divide both sides by 2. And so I get x equal 3 plus or minus 4i divided by 2. So 3 plus or minus 4i divided by 2. If you wanted to, you could have written it as two separate fractions. So you could have said 3 halves plus or minus. Now 4 divided by 2 is 2 though. So you got to say 2i. Either one of those fine. Remember, this is version 1. Over here, you want to solve by completing the square. All right, first step in completing the square is to make sure the coefficient of x squared is 1, and it is. And then you're going to bring the constant to the other side. So I'm going to get x squared minus 6x, leave some space, equal 2. All right, now, the next thing to do is take the coefficient of x, which is negative 6. You're going to take half of that. So I'm going to divide by 2. When I take half of negative 6, I get negative 3. Once you get negative 3, you have to square that. When I square that, I get 9, and that's what you add to both sides. You add 9 to both sides. If you're doing this correctly, this should now be a perfect square trinomial, meaning that when you factor it, those two binomials are the same, and they are. You're going to get x minus 3 equal, and then that's going to be 11. And so I'm going to write this as x minus 3 squared equal 11, and then we do the same thing we did here. We use the square root property. So let me go ahead and rewrite this over. So I'm going to take the square root of both sides, plus or minus. The square and the square root undo each other. So you get x minus 3 equal plus or minus square root of 11. And then finally just add 3 to both sides. And you get combined like terms at 0. You get x equal 3 plus or minus square root of 11. All right, and you can't do anything else. Those are not like terms. 3 and square root of 11 are different terms. The 3 is rational, square root of 11 is irrational. Together, this is an irrational number, though. Right, so that's version 1. Now in version 2, let's see what version 2 was. In version 2, we had this. Okay, so this was version 2. So again, we're going to use the square root property. So we have something squared equal, an expression squared equal a number, so I can use the square root property. So I'm going to go ahead and rewrite this over. All right, when I take the square root of both sides, don't forget the plus or minus. And so I get the square and the square root undo each other, so I get 5x minus 2 equal plus or minus 3i. Square root of a negative 9 is 3i. Adding 2 to both sides, I get 5x equal 2 plus or minus 3i. And then finally divide by 5. I get x equal 2 plus or minus 3i divided by 5. And if you wanted to, you could have written it as two separate fractions. You could have said 2/5 plus or minus 3i divided by 5. Either one of those fine. Okay, number 4, you want to use completing the square. So again, you got to make sure the coefficient of x squared is 1, all right, which it is. So then we're going to bring the constant to the other side. So I get x squared minus 8x equal a negative 2. And now we're going to take the coefficient of x, which is negative 8. I'm going to take half of that. When I take half of that, I get negative 4. Okay, now with that negative 4, I got to square this. When I square that, I get 16, and that's what you add to both sides. If you're doing this correctly, this should now be a perfect square trinomial. So in other words, when you factor it, you're going to get a binomial times itself. And you do, you're going to get x minus 4. So x minus 4 times x minus 4 is this. And that's going to equal 14. It's kind of always easy to remember, because if you look at 16, the square root of 16 is 4, so you need this to be a 4. It's a negative 4, though, because of this sign right here. All right, so you're going to take the square root of both sides. when I take the square root of both sides, I'm going to get, okay, these undo each other, square root and square undo each other. And I guess so I get x minus 4 equal plus or minus the square root of 14. And then finally add 4 to both sides. I get x equal 4 plus or minus the square root of 14. Alright, so I get this. Or you can just say 4, well, alright, so that's all you can say. Or if you want, you can write separately x plus, 4 plus the square root of 14, comma, 4 minus the square root of 14. Does not matter. Alright, now, this number 5 is on both versions of the test. Alright, so here you notice that this is a radical equation, in particular it's a square root. When solving a radical equation, I get the square root by itself, which it is. Once it's by itself, to get rid of the square root, so you see the square root, so the index is 2 right here. So to get rid of the square root, the opposite is to square both sides, just like this. Now, when I square x plus 4, remember that means x plus 4 times x plus 4, so you actually write it out. Use the FOIL method. So x times x is x squared, the outer is 4x, the inner is 4x, and the last is 16. Combine like terms to get x squared, 4x plus 4x is 8x, and then plus 16. So that goes here. So x squared plus 8x plus 16 equal, and remember the square and the square root, these undo each other, and so you get x plus 4. And then bring everything to one side, bring all the terms to one side, because this is now a quadratic equation. So I had a radical equation, and now when I did this operation, I now have a quadratic equation. So I'm going to bring all these terms to the other side to get x squared plus 8x plus 16 minus x minus 4 equals 0. Combine like terms, I get x squared plus 7x, 8x and negative x is 7x, 16 and negative 4 is 12. Alright, and then factor. And when I factor, I get x plus 6 times x, oops, sorry. I'll make sure I did this right. 16, that said 4, that should be 10. I'm not sure where I got 4 from, but that's 10 right here. 10, and that's going to be 6. 6. Alright, so I'm going to get x plus 6 times x plus 1 equals 0. And then using the zero factor property, I'm going to set each one equal to 0. And so when I do that, I get x to be negative 6 and x to be negative 1. Now, one of the things you got to remember, when you raise both sides of an equation to an even power, you have to check for extraneous roots. Alright, so let's check x equal negative 6. So you must check. You must go back to the original problem though. So the original problem is this, x plus 4 equal the square root of x plus 10. So when x is negative 6, I get negative 6 plus 4, which is a negative 2. On this side, I get the square root of negative 6 plus 10. And so this becomes a square root of 4, which is 2, and negative 2 does not equal 2. So negative 6 would not be a solution. Okay, negative 6 is an extraneous root. It's an extraneous solution. It's a false solution. So negative 6 is a solution to this, is a solution to this, solution to the original, this right here, but it's not a solution to the original problem. Okay, if you check negative 1, I get negative 1 plus 4, and that's 3. Over here, I get the square root of negative 1 plus 10, which is the square root of 9, which is 3. So those are equal. So that's the only solution. So negative 1 is the only solution. Okay, with number 6, now this is version 1. So number 6, remember when solving absolute value equation, you gotta get the absolute value by itself. The absolute value bar is the expression by itself. So you're gonna add 2 to both sides. So I get the absolute value of 4x minus 3 is equal to 7. Once you do that, then you're going to write it as 2 separate equations without the absolute value bar. So remember when we learn this, you're going to write it as 4x minus 3 equals 7. And the other equation, so these are going to be 2 equations that you can get from here. It will be 4x minus 3 equal to negative 7. Alright, now notice you went from an absolute value equation to 2 linear. So I'm going to add 3 to both sides. So I get 4x equal 10. And then when I divide both sides by 4, I'm going to get x to be 10/4, which is 5/2. Over here, add 3 to both sides. I get 4x equal -4. Divide both sides by 4, and so I get x to be -1. So that's your solution, 5/2, comma, -1. All right, now that was the one in version 1. Let's see what it was on the other version. So on the other version, this was what it was right here. So again, you're going to do the same thing. You're going to get the absolute value expression by itself. So you can add 4 to both sides. So I get the absolute value of 3x minus 5 equal 10. And then at that point, you're going to write it as two separate equations without the absolute value bars. So I get 3x minus 5 equal 10. 3x minus 5 equal a -10. And then you just solve each linear equation. So you're going to add 5 to both sides. So I get 3x equal 15. So when I divide both sides by 3, I get x to be 5. Over here, add 5 to both sides. I get 3x equal -5. -10 plus 5 is -5. Divide both sides by 3. I get x to be a -5/3. And again, you don't have to check these like you did with the radical equation, because I raised both sides to even power. Here you don't have to check. All right, so the solutions are x equal 5, comma, x equal -5/3. All right, number 7. Okay, so number 7, I think, is number 7 is different. Oops, sorry. Number 7 is the same on both versions. All right, so you want to find the midpoint. So the midpoint formula is this. That's where you're going to add your x coordinates together. So x1 plus x2 divided by 2. And you're going to add your y coordinates together, y1 plus y2 divided by 2. And so it's a good idea to label these. They'll be x1, y1, x2, y2. So those are the x coordinates and y coordinates of the first point. These are the x coordinates and y coordinates of the second point. All right, you just substitute. So I get -2 plus 8 divided by 2, comma, and then -1 plus -4 divided by 2. And so this becomes -2 plus 8, 6/2, comma, and then that's -5/2. And so when I reduce, I'm going to get 6/2 is 3, -5/2. Okay, now here you want to find the distance between these points. So the distance formula is this. So it's the square root of, and then you're going to subtract the x coordinates from each other. So x2 minus x1 squared. And then you're going to subtract the y coordinates from each other, y2 minus y1 squared. All right, and then you're going to substitute. So you're going to get distance is going to equal, and let's see, it'll be the square root of, it says x2, so you're going to say 8 subtract a -1. I'm sorry, -2 rather, -2. And whatever that is, you're going to square it, plus, and then you're going to subtract your y coordinates, -4, subtract a -1 squared. All right, so I'm going to get 8 subtract a -2 means 8 plus 2, which is 10. So that's 8 plus 2 squared. And then this becomes -4 plus 1 squared. And so that's going to be the square root of 10 squared. Plus, and then -4 plus 1 is a -3, but I'm squaring that. And so that's going to be the square root of 100 plus 9, which is the square root of 109. All right, now 100 square root of 109 cannot be simplified, so I'm going to write it as square root of 109. And then on your calculator, use your calculator because it says approximate to 2 decimal places. So when I do approximate to 2 decimal places, I'm going to get 10.44. All right, so that's number 7. All right, now number, okay, so these are on the same versions, on both versions. All right, so here you want to graph, the graph of the circle is given, and so you want to answer 9 and 10 based on this graph. All right, so you want to find the domain. So remember, it's a good idea to use something like a ruler to help you with this. So remember, the domain is a set of x coordinates. So let's go from left to right along the x-axis like I'm doing. So as I go from left to right, notice that the smallest x coordinate on the graph, on the circle, is -9. with a bracket, and then the largest x coordinate is a positive 1 with a bracket. And then for the range, the smallest x coordinate's negative 2, I'm sorry, the smallest y coordinate's negative 2, and the largest y coordinate is positive 8. So negative 2, positive 8, and then let's see which one it is. So that should be, I think it's this one. All right, letter C. Okay, then it says, which of the following represents the equation of the circle above? So remember the equation of the circle is this: x minus h squared plus y minus k squared equals r squared. And so the center here, remember, is hk, and the radius is r. So here, the center is negative 4, 3. Negative 4, 3. And so when I substitute hk, h is negative 4, k is 3, into here, I'm going to get x minus a negative 4 squared plus y minus 3 squared equals the radius. Now the radius is the length from the center to the circle. And so let's go ahead and use this horizontal distance. That's 1, 2, 3, 4, 5. So it'll be 5 squared. So your radius is 5 units. Now, I rewrite this because you should know that x minus a negative 4 means x plus 4 squared, and then y minus 3 squared equal 25. All right, so you got to say 5 squared is 25. And so that's going to be x plus 4. That's going to be this one. All right. Okay, number 11. Number 11 is, this one's on version 1, right here. All right, so you want to graph the circle. So you got to find the center and the radius. So remember, just like a while ago, the equation of the circle is x minus h squared plus y minus k squared equals r squared. And so the center is hk. Now here, a mistake you're going to make is you're going to say that h here is 5, and it's not. So remember, you need to write this in your mind. You need to say x minus a negative 5, because that's what x plus 5 is. X plus 5 is x minus a negative 5 squared. And then see here, you need to write this as y minus 0 squared, because y minus 0 squared is y squared. So make it look like this, so you can actually see h and k. And that's equal, and then 16, remember, is 4 squared. 16, 4 squared. All right, so therefore you know the center. So the center is negative 5, 0, and the radius is 4. And so the way I would do this then is I would locate the center, negative 5, 0. So that's right here. And then from that center, I would go 4 units to the right, 4 units up, 4 units to the left, 4 units down, and then draw the circle. All right, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And just do the best you can with drawing the circle. Make sure it looks like a circle. Oops, did this wrong. You have a pencil so you can erase. Do the best you can. All right, so there's your circle. All right, so that was version 1. On the other version, let's see what that was. All right, so on the other version, same idea. You're going to say x minus a negative 2 squared plus y minus 0 squared equals, and then 25, remember, is 5 squared. And so the center is going to be hk, so negative 2, 0, and the radius is 5. So I locate the center, negative 2, 0, and from that center we go 5 units to the right, 1, 2, 3, 4, 5, 5 units up, 1, 2, 3, 4, 5, and then to the left, 1, 2, 3, 4, 5, and then down, 1, 2, 3, 4, 5. And then just to do the best you can with drawing this circle. Make it look like a circle though, not like a like segments. Do the best you can. You have a pencil so you can erase. Okay, now finally, number 12, you want to solve the system by graphing. All right, so, and I think it's the same on both versions. So let's see, yeah, it's the same on both versions. So you want to solve the system by graphing. So remember, when you solve the system by graphing, the solution is where the two graphs intersect. That's the solution. All right, so let's look. We have y equals negative 4x plus 4. The way I'm going to do that is I'm just going to use the idea of slope and intercept. So the slope here, since y is by itself, that's slope-intercept form. So the slope is negative 4, so that's negative 4 over 1, and the y-intercept is 4. All right, so from here, remember you want to graph a line. To graph a line, this is linear, so that's a line. To graph a line, you need 2 points. The y-intercept is one of them, so that's 4, right here. And then from here, I'm going to use rise over run. Rise over run. All right, so since my rise is negative 4, I'm going to go down 4. 1, 2, 3, 4. And then since my run's a positive 1, I'm going to go to the right 1. All right, now do the best you can with drawing this. Is see how I kind of did my points too thick? So it may not come out very well. But we have a pencil, or you have a pencil, and so you can erase. Mine's not a pencil. All right, so let's do the next one. Y equal negative 1/2 x minus 3. So same idea. The slope is negative 1/2, and the y-intercept's negative 3. Negative 3. All right, so to graph a line, I need 2 points. The y-intercept is one of them. So that's this right here. And then from here, I'm going to use rise over run. So my rise is negative 1, so I'm going to go down 1. And my run's a positive 2, I'm going to go to the right 2. And so I think I should have used a pencil here. But let's see. It's because it really should intersect here. So this wasn't a very good graph. But I'll do this. All right, so even though it looks like intersected here, it's really here. All right, so make sure, and these points aren't plotted very well, so that could have an effect on what the graph looks like. But it looks like the solution is 2, negative 4. 2, negative 4. And you can always check. You can always check. Go back to the original. So here's x, here's y. And so if you check, you have y equals negative 4x plus 4. Check the first one. So y is negative 4, so you want to see is negative 4 equal to negative 4 times x. X is 2 plus 4. Negative 8 plus 4, which is negative 4, which is what this is. But it's got to work with this one as well, so you got to check both of them. So y equals negative 1/2 x minus 3. So is negative 4, y is negative 4, so negative 4, you want to see that's going to equal negative 1/2 times 2 minus 3. Negative 1/2 times 2 is a negative 1. Negative 1 minus 3 is a negative 4. All right, so that does work. All right, so that's going to take care of the key to both versions 1 and 2 of Test 1.